Good afternoon, everybody. My name is David Jones. I'm the director of the GreenPages hybrid cloud data center practice. I guess I did my hands. Today we're going to talk about autoscale groups and RDS. I call it Autoscale Group 101, RDS 201, because I don't talk about the basics of RDS much. So a little bit about me. Like I said, I am the director of our hybrid cloud data center practice that typically entails VMware's product line on the private cloud side and AWS for the public cloud. I'm an AWS Solutions Architect professional. I have all three of the base associate certs. VMware Certified Design, VMware Certified Implementation Expert on data center. About 12 years with VMware-based virtualization and 6 with AWS. So I got into this virtual thing and really stuck with it. I say all that, though, to say I am an infrastructure guy. I am not a machine learning guy. I am not a developer. I'm not a programmer. So if the questions start going that direction, I'm just going to start shooting them down. So all right, so the agenda. Like I said, I try to keep this Autoscale 101 and RDS 201. We'll talk about why autoscaling is so cool, what it is, the components, and then how we use it along the lines of, how do you address a pool of compute as a single entity. We'll talk about RDS 201. It'll be high availability and multi-AZ more than what it is and how it works. We'll talk about scalability as well, and then we'll see it in a real-world setting. There's a lot of topics, a lot of presentations that talk theoretical. I learn best by getting my hands dirty, and I like to think everyone thinks like I do. So we'll do it that way, and then there should be plenty of time at the end here for Q&A. All right, so Autoscale 101. Is anyone in here thinking about taking the SysOps Administrator exam? By show of hands. All right, you're going to want to pay attention to this section. It features heavily on the exam. All right, so what is autoscaling? There are like 2 slides that I might actually read something directly off the slide. EC2 autoscaling helps you ensure that you have the correct number of EC2 instances to handle the load of your application. And that's the key word, is it's load-based. So we're not just going to spin up instances to meet a certain quota, to make sure that we have a certain availability, which we could. But this is load-based. And we'll see that here in a minute. You create a collection of instances called a group, and it's a single management construct at that point. So you manage a group as a single entity rather than a pool of EC2 instances or several EC2 instances. You specify the minimum size, and Autoscale Group will always make sure that you have at least that. You specify maximum size. We don't necessarily, we're paying for every bit of compute that we use. We don't want this thing to scale infinitely and run our bill through the roof unexpectedly. And then we have a desired capacity, which AWS will make sure that you always have that desired capacity whenever possible. And the key takeaway from autoscale groups, those instances within that autoscale group become cattle rather than pets. Does everyone know the cattle versus pets paradigm? I think this guy back here was like, oh, again, yes. Yeah, cattle versus pets, absolutely. All right, so why do we use autoscaling? Variable load patterns. I like to think, the example I like to use, e-commerce sites around the Christmas holiday shopping season, tax preparation sites in February, March, April, when everyone is jumping on H&R Block to do their taxes. Those organizations don't need to maintain that capacity year-round. It's just not economical. Hardware failure. Virtualization really made this easy. It goes back to dealing with VMware for 12 years. Let's take out the hardware altogether. That stuff fails all the time. Autoscaling will not only deal with it like VMware does or whatever. It will actually rebuild stuff. It will expand based on hardware failures. And then cost optimization, like I mentioned with the variable load patterns. We need to keep this to a manageable consumption model. We don't want to have an unnecessary amount of capacity sitting there unused that we're paying for. So components of autoscaling. I mentioned autoscale groups. This is the group of compute that we manage as a single entity. We have our launch configurations. Launch configuration is simply a template for deploying an EC2 instance. It's very similar to running through the instance deployment wizard. You just don't provision an instance when you get done. And then we have scaling policies. And scaling policies dictate when we scale up or scale down. We can do it conditionally, which is considered dynamic scaling. We can do that based on a trigger. If we violate a certain threshold, we can spin up additional instances. Or we can do it on a schedule. If you know that you have an upcoming event, if you have a digital marketing campaign that's going to launch at 5 o'clock on a Friday afternoon to advertise, your local drinking establishment for happy hour, you might want to have the resources sitting there waiting for you or for your users when that marketing campaign goes live. So the components of autoscale group, and I'm going to run through these really quickly because nobody likes to look at screenshots. So we have our scaling policies. We'll talk about these on the next slide. Our launch config, again, this is, for those of you who might come from a Windows environment, think sysprep. It's kind of a scripted manner in which we're going to stamp out these instances over and over again. We have our target groups, and we'll get into these in detail in a little bit. It's essentially the group of instances that are managed by or load is distributed by an elastic load balancer. And then we have our health check grace period. So this health check grace period right here is very important. It's essentially how long autoscaling will wait to check the health of your instance. If it's set too low, so if you get too aggressive with it, it will start to terminate your instances before they've had a chance to come up and come live. It will see them as unhealthy, and it will terminate them. And it's very easy. Set that to like 30 seconds, and you'll just see constant churn in your EC2 console. But if you set it too long, then they sit there idle and unused for an unnecessary amount of time. All right, so our scaling policy we talked about a minute ago. And I don't know if you guys in the back can see this. I gave this a while back in a much larger room, and everybody got up and moved forward. So essentially what this particular scaling policy tells us is when the CPU of our instance hits 80%, go ahead and scale out. It's a quick and dirty. If you want to play with EC2 autoscaling groups, go build one. Use just the standard Amazon Linux image. Install the stress package, and then you can literally tell stress to peg the CPU, and you'll see instances just start to spin up. It's really cool. It literally takes like 10 minutes to do, and you can actually see it live. It's very slick. You can define your trigger out of the box. They do average CPU utilization we're using here. We do network bytes in or network bytes out. That's actually a really good one if we're talking web traffic is an example, is an excellent example of that. We can do application load balancing requests per target. So that's probably real world going to be one of your better metrics to use there. Because at that point, it's based on what's coming from the load balancer. And you could start to spread the traffic out or expand your capacity based on the actual network traffic you're getting in. Network bytes in or out can be kind of dodgy. CPU, I mean, depending on what you're doing on that machine, it might not be triggering a lot of CPU usage. But you start to see those load balance requests go up, and that's going to be a pretty good indication you need to scale. You can also leverage CloudWatch metrics. So you can build custom metrics within your instances, have them ported out to CloudWatch, and then circle back and use scaling policies to trigger events based on those CloudWatch metrics. So when you get into that, you can basically trigger on any metric you can come up with. As long as you can compute it and spit it up to CloudWatch, you can trigger autoscaling. And then we start talking launch configuration. So launch configuration, again, like I mentioned, it's basically like running through the wizard to generate an EC2 instance, but no instance is actually generated at the end. We can specify things like our AMI ID, generic Amazon Linux instance. It could be one that you've custom built. We'll talk about that in a minute. I highly recommend it be one you custom build rather than a generic one. The instance type, in this case, we're using an M4 large. It could be a T3 micro or T2 micro. I actually had a problem the first time I gave this presentation and included hands-on, and we were using T2 micro instances on our web servers, and we couldn't get auto-scaling to trigger because stress was stressing the CPU to the point we ran out of CPU credits, and it just wasn't doing anything with them anymore. So we had to switch them to M4 larges for the purpose of the demo. Specify your key pair, your security groups. so on and so forth. Like I said, everything that you specify when you generate an EC2 instance essentially ends up in your launch config. Now, our user data is key. This is where we actually customize our EC2 instance. And this happens to be one for Linux. Again, I don't know if you guys can read it. There are a couple of things wrong with this. And I've asked in the past if anybody sees the bad idea here. Our very first are basically to upgrade all packages on the host, on the instance. I would definitely not recommend doing that because as you start to scale out, you might have an instance that's a few months old, and then you've updated all the packages on the new one, so you could have version mismatches across nodes. It may not be a bad idea, or it may not be a bad thing, but it's a terrible idea. So I would not recommend doing that. But this basically installs our EFS utilities, Apache, PHP, Stress in the case of this demo. It mounts an EFS target to our var www root so that basically we get all of our code directly mapped into EFS. And then it starts Apache and makes sure it comes on when the machine boots. So this is actually, EFS will give you all of this right here. So this isn't even, you don't even have to know how to do this. You go to EFS, you click on your file system, and it gives you the commands to mount in your instance. So what do we do with this? So now we've got, I don't know, let's say 10 EC2 instances running an Apache web server. How do we address them? We could point Route 53 at the first one and hope that first one never goes away. Or we could put it all behind a load balancer, which is going to make a lot more sense. So Elastic load balancers allow us to statically address dynamic workload. So we could have one EC2 instance, we could have 10 EC2 instances, and the load balancer will take care of distributing that load across all of the nodes, provided they are listed as healthy. So we do this with target groups. So I mentioned earlier when we build our autoscale group, we pointed at a target group. And essentially, this is just registered targets for the load balancer. Does that all make sense? It should be fairly straightforward. And then the load balancer routes all the requests that are to all of the targets that are registered as healthy within the AZs that are registered within that load balancer. So that's an important point. You could have autoscaling spit out, Northern Virginia has 6 availability zones. You could have an autoscale group that provisions to all 6 AZs. But if your load balancer is only registered to 1 and 2, you're going to have 4 AZs worth of workload that's not even getting leveraged. So that's a good gotcha that you want to pay attention to. So we start talking target groups. We have our load balancer, and we'll talk about this in a minute, but it basically tells you what load balancer this target group is set for. And then we have our health checks. And the health check basically just checks the health of the instance to see if it's valid. So we have our path on our health check. We have the path. In this case, it's just the root of the web server. I've actually got a customer I've dealt with that they didn't want to do that. They didn't want to check to make sure the home page was alive. They wanted a special healthcheck.php or something, and I think it just made sure the database connection was valid. A very minimal lift to that application. So it wasn't loading the entire website. It was just basically a PHP connection check to RDS on the back end. Something that wouldn't be too taxing on the server. And then you've got the success code, and 99% of the time, if it's a web server, you're just looking for HTTP 200, which is a success code. So, and then we start talking load balancers. So, key exam topic here. You never get an IP address for an Elastic load balancer. It's always this crazy custom DNS entry that didn't use Route 53 to point to. So you'll never get an IP address on an Elastic load balancer. That is a very key topic for those of you looking at the SysOps exam. But from there, we can use Route 53 to provide multi-region availability. And we'll see this actually in a few slides where I have a global diagram of a web application that is essentially spread to, I didn't do every region. That would have been, that diagram would be absurd. But you could basically do geo-based routing for performance purposes. Someone in Australia can just hit Sydney rather than coming all the way back to Virginia, for instance. And for customization. especially with like GDPR over in Europe. You know, you can keep all of the European traffic in Europe and maybe direct all the North American traffic to North American servers and so on. All right, so gotchas for autoscale groups. And I don't know if you guys are familiar with AWS Drinks hashtag, but if you get bored, you should check it out. So autoscale group, you order a beer and 20 friends come join you. Bartender dawdles about, your friends get up and leave, and the bartender brings you 80 drinks. So what this, and this is a very, very, very common ASG issue. So you have a spike in load. Your web server starts getting hammered. It takes 5 minutes for you to spin up additional instances within your autoscale group, get them registered to your load balancer, and go. Your users have given up in 5 minutes and have moved on to something else, and now you don't need that capacity anymore. Very common issue. So how do we handle that? Prep your machine image. I mentioned this earlier. Don't use the generic Amazon Linux image and then install a bunch of code and a bunch of updates. Get your application installed on the AMI. You know, create a custom AMI that's ready to go so that when it spins up, it basically just has to boot and go. Tune your health checks. Ensure that ASG events trigger before the capacity is needed, if at all possible. You know, setting CPU to 80% may not be good. If you know that that application runs about 20% CPU, 99% of the time, maybe when it hits 40%, you start triggering ASG events so that you have capacity ready and waiting as that load ramps up. And then finally, give your instances time to deploy. I mentioned earlier that health check grace period. You don't want to start this infinite loop of build and destroy because you're not giving enough time to your instances to spin up. Oh, and one that I love to point out on this one, if you're familiar at all with Windows, and this was a common problem I ran into when we started virtualizing, you know, way back in the day, the first wave virtualization stuff. Customers would complain that deploying a Windows template still took forever because of sysprep. It can take, what, 10 minutes to sysprep a Windows machine. And, you know, I tell them, your physical servers would take 20 minutes to boot, plus add, you know, 10 for sysprep. We've taken out that 20-minute post time on the physical host, but we can't virtualize sysprep. Microsoft's still going to make you do it. They're still going to make you run through that customization period. So especially if you are using autoscale groups with Windows, either don't sysprep them. Nobody here is from Microsoft, right? Either don't sysprep them or make sure that you tune that grace period appropriately. All right, so RDS 201. Again, I'm not going to talk about what RDS is. Hopefully everyone in here knows that. But it is, at a very high level, Amazon's hosted database service. I think we all know that. The topics here, if anybody is interested in their SA professional exam, these topics feature on the exam. So this gets into a little more in depth. This was originally going to be a 101 talk, but the 101 stuff just wasn't very interesting. So we modify it slightly. All right, so high availability. We're going to talk about high availability, then we're going to talk about scalability. So in multi-AZ deployments, RDS will automatically provision and maintain a synchronous standby replica of your data. In the event the primary fails, Amazon will automatically flip the instance over to the standby. It does this obviously for data redundancy. I mean, that's a given. It also does it to eliminate I/O freezes. So when you do backups on a single instance database, you can actually see performance hits while it takes that snapshot. You'll see I/O slow down. So it actually makes it much easier. Any maintenance that's done against a multi-AZ RDS instance will actually be done against the standby. So you don't have any of that maintenance hitting your primary live database. That's everything I had on this slide. Sorry, I jumped ahead. So RDS handles the failures for you automatically. That's the key thing here. You basically point your app at a DNS entry, and you go. Amazon handles where that DNS entry points. You don't have to worry about going in and automatically flipping the switch, flipping the application to point to the standby server, making that standby server live and capable of reading and writing data. Amazon takes care of all of that. It switches over automatically for any of these reasons. So if an AZ outage occurs, it does happen. If the instance fails, if the primary database instance fails for whatever reason. If the instance classes change, if you've noticed that the performance isn't quite up to snuff and you want to bump it from a large to an extra large, for instance, it'll automatically fail over. If Amazon happens to be patching the OS on that instance, they do run an OS under them. And then if you manually fail over with the reboot with failover option checked, if you plan on taking an exam, you want to remember that one. But the key here is without admin intervention. You're not going to get called at 4 in the morning when your database instance dies and you have to get up and flip the switch. Amazon will take care of all of that for you. So what we have here, we have our database with our master running in, we'll call this AZ1. It goes away. Amazon flips a switch, makes the standby now the master. And then once whatever is resolved, if it has to redeploy that instance or whatever in AZ1, it will actually reverse the replication, and you'll now have a new standby. So again, Amazon takes care of all of this for us. We don't have to deal with any of this headache. All right, so there are some gotchas with the HA. You may have increased read and write latency, or write latency specifically. So because it's synchronous replication, the write is not considered committed until it's written to the standby. So Amazon, within a region, the network connectivity is excellent, but there still is that secondary write that has to occur. So you may experience some write latency. You actually may have a change in latency when that failover occurs. So if your primary application runs an AZ1 and your primary RDS instance gets flipped over to AZ2, you may actually see some additional read latency as it goes across the wire to that second data center. And then for production workloads, I think this should basically go without saying. Provisioned IOPS and using instance classes that are M4 large or larger that are optimized for provisioned IOPS. The key here in red, high availability is not a scaling solution. That is extremely important. You cannot do anything to that standby replica. You can't serve reads from it. You can't write to it. You can't do anything. That's when we start talking about read replicas, which just so happen to be the next slide. So, all right, so scalability. RDS provides read replicas to enhance performance and durability. So a read replica, I don't want to get ahead of myself, sorry, let me slow down. So they allow you to elastically scale out beyond the capacity constraints of a single instance. And what this allows us to do, and I've got this will be much bigger here in just a second. It allows us to create one or more replicas of a database instance to serve high volume read traffic. And then we can promote those read replicas to standalone database instances. So think like promoting a production, or I guess demoting a production database to dev. You can create a read replica of it, get very recent production data. Sorry, I just got my laptop wants to update. So you can create a read replica, get very recent copy of your production database, and then basically promote it to a standby database and give it off to your developers to start hammering against the latest version of your database. You don't have to sit there and manually create an additional database and load it with useless data or development data. So what we have in this instance here is I think this is US East 1, we have our master database where all the writes go to and some reads. And then over in Oregon, I think that's Ireland, Tokyo, Sydney, and Sao Paulo, we have read replicas. And in this case, all of the reads stay local to the region. I'm from Atlanta. I like to think of this as like CNN.com. So stories are written and updated in New York or in Atlanta out to US East 1, and then they get pushed out to the rest of the world. So users hitting CNN.com in Sydney don't have to go all the way back to Virginia to get their news stories. And there's really no writes that need to occur from Sydney necessarily, except maybe updating traffic statistics or whatever, for advertising. So that's one of those real-world use cases. Something that you're going to push out from one location across the world, and there's not going to be a lot of heavy feedback from the rest of the world. Another instance is something like a BI or a reporting tool. You can start to push out those. You can start to point your reporting tool or your dashboards to a read replica rather than the master database, and then its reads are not going to affect the performance of the actual production database. This is another good exam topic. All right, so when do we use read replicas? Again, I mentioned earlier, scaling beyond the capacity of a single instance. Serving read traffic while the source database is down. So in our earlier example, in the event that CNN.com and US East 1 goes down for whatever reason, the rest of the world can still read their news articles. Just as long as, and Route 53 theoretically, and we'll look at this in a minute, Route 53 could actually just mark US East 1 as dead and never send any traffic to it. So we could keep CNN.com alive. Right? CNN doesn't see this and get on to me for a reason. And then again, I mentioned business reporting or data warehousing. You don't want those reads. You don't want to generate a dashboard or a regularly generated report from your production database necessarily, because it's just going to start to crush it. And then read replicas are available on Aurora, Postgres, Maria, and MySQL. So basically no Oracle, no SQL Server. And then this is important. Scalability does not equal high availability. So I mentioned earlier, you cannot serve traffic, read or write, from a standby replica in a multi-AZ. This is a bit of an eye chart, and I don't love this slide. I'm going to be perfectly honest with you. But this is straight out of Amazon's documentation on read replicas in multi-AZ. So in multi-AZ, synchronous replication is highly durable. It's immediately consistent, master to standby. Read replicas, it's asynchronous. So it's highly scalable, but it may not be up to the second accurate. Only the primary database engine is active on the multi-AZ. All read replicas are accessible and can be used for read scaling on the read replicas. Backups are taken from standby. So again, we don't want to hit our primary instance and have those I/O freezes on our primary instance. And there is no backup on a read replica. If it blows up, you just create a new read replica. That's kind of the beauty of it. Multi-AZ deployments always span 2 AZs in a single region. Who knew that multi-AZ meant more than one AZ? And then on read replicas, it can be within an AZ, across an AZ, or across regions, like we just saw on the map. Database engine versions upgrade on the database version upgrades happen on the primary with your multi-AZ, and engine upgrades on a read replica are independent of each other. So you could have SQL 2016 running on the primary, and it could be 2012 on the read replica for all we care. It doesn't really matter as long as our application knows how to handle it. Thank you. Yeah, it was just, I wasn't going to try to come up with a MySQL version off the top of my head. And then with multi-AZ, automatic, you were paying attention though, very good. And in multi-AZ, we've got automatic failover to standby. And with the read replicas, we can manually promote them to a full-blown database instance if we need to.
When you say standalone instance, how does that map into your multi-AZ?
So basically, you can promote a read replica to just a single node database. Actually, to be honest with you,
So you're losing your API?
well, so you can just create another read replica. So you can promote that one to a standalone database and then create another read replica to replace it if you wanted to. Just,
Right, but that's not your standby.
so we're talking read replicas can be manually promoted. Your standby is just your standby. You can't really do anything with that standby in a multi-AZ. But with your read replica, you can take that read replica, promote it to a full-blown database, a read-write database, and then backfill it with another read replica from that first database. Does that make sense?
Well, yeah, but if your primary goes down and you go to your secondary,
Yep.
now you have no secondary.
Amazon will take care of recreating that basically restoring the fault tolerance there. Sorry, that's an excellent question. Thank you for, I didn't clarify that. So yes, his question, I don't know if everybody heard it. So in the event of the failover, the master fails, we fail over to the standby and multi-AZ, AWS RDS will take care of recreating the standby somewhere else, whether it's in a different AZ within that region or just backfilling it in the same AZ. So thank you for that. All right, so real world, when would we use this? This is a design I've actually implemented. It's dumbed down. I removed Elastic Cache and some other things, but this is a very basic. We've got this actually just happens to be in US East. That's where we built it. But we have our Bastion host, and the Bastion host is actually sitting in a public subnet with an auto-scale group that scales both AZs. It has a minimum capacity of 1, a maximum capacity of 1, and a desired capacity of 1. So basically, if anything happens to the Bastion host, it will be recreated, but we don't need to have multiple of them. They're not there for load. That's there for availability. And then down here in our private subnets, we actually have our web server auto-scale groups that are fed by an elastic load balancer that all the traffic comes in from the internet gateway. So you'll notice from the internet gateway to the elastic load balancer, we have port 80 and port 443, so HTTP and HTTPS. But from the load balancer to the web servers, we only have port 80. If you terminate your SSL connections on your elastic load balancer, you don't have to maintain SSL certs on all of your EC2 instances. So if for some reason they get compromised, you don't have to go back and fix your AMI and recreate all that. You just change them on your load balancer and you go. So it makes something like SSL certificate management very easy. And then we have, in this case, we have our PHP code or HTML or whatever living on an EFS volume that our web servers automatically mount, like we talked about at the user data piece. I see head shaking back there. Is that a hard no? Oh, okay. Sorry, you seemed very, very adamant that we don't want to do that, so I wanted to make sure. And then we have our web servers reading our RDS master with replication over to the standby. So this is a relatively simple, 3-tier web app, or 2-tier web app in this case, where we have our redundant web servers managed by an autoscale group and a load balancer, and we have redundancy with our database. By the way, this looks like that in the CloudFormation template. It's 430 some odd lines of code that is just both beautiful and terrifying at the same time. So what can you do with this? This is maxing that out. This would only work in Northern Virginia because it's the only one that currently has 6 availability zones. But again, we can scale out that Bastion host. With an elastic IP, it doesn't matter which AZ it lands in. It's going to be OK. We've got our web servers down here that again can scale or can span across all 6 AZs. We can only have 1 RDS standby, so it's basically going to be AZ 1 and 2. If 1 goes away, then 2 becomes active, and it may put it on 3. Like if that whole building gets fiber cut or multiple fiber cuts in that case. And then EFS is ubiquitous, so it's going to be spread across that entire region without having to do anything super special with it. All right, and then I talked about CNN.com, and this is kind of this is pulling it all together, I think is the way I would demonstrate this. So again, we have our masters, our master database in Virginia. We have read replicas all over the world. We've got Route 53 distributing traffic again. So for instance, if a user in Japan goes to CNN.com, they might get CNN Japan rather than CNN America. And they can do that with geo-based routing through Route 53. Any questions? I cannot believe I got through that as quickly as I did. I really thought I was going to be talking well past my allotted. Yes, sir.
You have your load balancer, and so you're going to scale up instances of containers of web apps. Those instances need to be registered with the load balancer.
Yes, sir.
Okay, so we can say, hi, here I am registered. When you scale down, how do you deregister?
Actually, Contraction happens automatically. So the autoscale group will recognize that you no longer need all of that capacity, and it will start to remove instances, and it will remove them from the target groups automatically.
Even though that instance registered itself?
Yes, yeah. Amazon does a great job of making sure that all of, so the elastic load balancer looks at the target group. The autoscale group is responsible for keeping that target group up to date. So if it removes an instance, it's going to remove it from the target group as well. So it just, and you actually, something I didn't cover, there's a cooldown period. So once it flags an instance for decommission, you can specify how long it should wait before doing that in case there are open sessions to that. And it just won't pass any new sessions to it. So basically, the load balancer will say, okay, I know number 5 is due for decom. I'm not going to send any more traffic unless it's already established. Yes, sir.
So,
I got you next.
so the S3 will say that okay, first with the replication we will set up, then we will compromise. We need to get that data access from one region to another region.
Mm-hmm.
We need to compliance with the policies one day plus a weekend. But in the case of replicas, are we doing same compliance for this replicas step?
So generally speaking, your application, if you're doing read and write, let me make sure I understood your question right. So with a read replica, if you're writing to, so if you're writing here and reading here, you'll have 2 different endpoints.
Yeah.
So you'll have a read endpoint and a write endpoint, and your application has to be able to handle that. Does that answer your question?
No. So assume like there is a GDPR issue because
Okay.
the European region can be only the
Yep.
but globally you don't have any replica for the European region, right?
Okay.
So suppose in case of the Japan data, they cannot execute the policy they are bringing up saying that okay, I don't want to read from Ireland data to over here. So
Okay.
what happens in the case of read?
So, okay, I think I see what you're saying now. So if you've got data in Europe, in the European region there, you don't want it out to the rest of the world. So first of all, you would have the application running on these EC2 instances in Japan. It would be pointed at the read endpoint in Japan. But the problem is all of your data in this case is going to be coming from the master since it gets written to the master and then pushed out to the reads. So really, we couldn't address that issue. We would have to re-architect the application, essentially, in that case. Yes, sir.
Are there changes now to the way you interface with the EKS products?
With the EKS products, I'm going to go ahead and say that's beyond the scope of this discussion. I would imagine it's relatively the same, but I can't speak to that, unfortunately. I don't have a lot of Kubernetes experience, personally. Yes?
Why is there no servers in Africa?
I cannot speak to that. I don't work for Amazon. I don't get. I do know that there is Saudi Arabia coming online, and maybe I know Saudi Arabia for sure, but I don't know. I would assume supply and demand.
I mean, Nigeria and South Africa, like, there's good amount of ID. So.
Gotcha. Yeah, I can't answer that, unfortunately. I don't work for Amazon, so I can't speak for them. There were some more. Yes, sir.
Regarding the preparing the machine image, you said you should not install this program images at you. Right?
If possible.
How about the cost? Is there a cost difference?
I mean, I guess it depends on the application. So you're going to pay to store that snapshot. If the application install results in multiple gigabytes of install, you have to look at the trade-off of cost of it sitting there. I mean, you're going to pay
So there could be a
pennies. Yeah, but at the same time, if you're installing an application that's going to result in gigabytes worth of change to your image, that's going to take a while. So, it's going to affect the amount of time it takes to scale that
is
application
there
up.
a way to, let's say, deploy the master image quickly to the target node?
I mean, that's the point of creating an AMI is go ahead and get it installed, and it'll just spin up additional instances from that AMI. That's the way I would do it. Yes, sir.
The other scaling actually suppose if you're making an image for a license after you on it. So when you do the auto scaling, so how does the license going to work on the
I'm going to say it depends on the application. Everything just the way it's just going to depend on the software vendor and how they want you to handle it.
I don't know whether
Yep, I know with like,
Remain compliant to the license agreement is the question.
Yeah.
Whether or not you do, I think it depends on how it's bound. I mean, most of the stuff that I've seen is bound like, hey, out of the box, it's here. If you have third-party products and it's bound to a CPU or.
that's when you get into
IO,
like dedicated instances. Yeah, you basically get in dedicated instances at that point. I know that's pretty common with Windows and Oracle, yeah. Those are gonna be the two I said. So yeah, I mean, that's gonna be a check with your software vendor. I hate to be that way, but they're all kind of, they all have their unique challenges. Yes, sir.
So when you set up an auto scaling group for EC2, can you have a bounded set of elastic IPs? When you auto scale, to like X additional number of instances, I mean, is it at all possible to,
So
assign
actually,
a group of IPs?
in this case, you don't really have elastic IPs. You're gonna get private IPs back here, and the IP address, or you're gonna access everything through the load balancer. So we don't really care about IPs here. We only use an elastic IP up with the Bastion host because it's publicly
Well,
accessible.
let's say that you're doing that in a public subnet.
Okay.
How would you do it? Is it possible?
Again, you're going to put in a load balancer in front of it. So I mean, you basically could address them individually by elastic IP, but you're going to end up, like you said, with an abundance of elastic IP addresses that you're going to be paying for and maybe not using.
Because there are situations where you have applications running on a particular set of servers, and those IPs get hard-coded in like
Yes, they
client
do.
firewalls. So
Yeah.
how do you manage that?
I mean, that's the purpose of an elastic IP. If once you assign it, if you tear that down, you should theoretically get that same IP back. So that would come down to just managing elastic IPs. I mean, just making sure that you have an appropriate number, that you're within the maximums and all that good stuff. But yeah, I mean, you're right. There are some instances where you would want to put this out into the public subnet, and that's just going to be something we've got to consider when we architect the solution.
So after the auto scaling happens, you need to have a script to assign these elastic IPs to the new instances, and then take them down when they.
Yeah, essentially you would have you would basically have a pool of elastic IPs waiting to be assigned. But yeah, that's how I would probably do it, is in the user data. One more. I would do it here. Basically, when it spins up, use the AWS CLI command. And I don't know what it is off the top of my head, but basically to assign an elastic IP address to that instance. That's how I would do it.
Okay.
Yeah.
If you brought back any best practices from AWS to on-prem to VMware things, such as not having super long-running server VM instances, and your infrastructure as code.
So I heard a lot in that question. I want to make sure I get it right. So have I got any best practices from maybe AWS on like hybrid cloud?
Anything you treat VMs differently on VMware based on things that you've learned in AWS?
So VMware doesn't have native, well, this is a bit of a loaded answer. VMware doesn't have anything this easy for treating VMs like cattle rather than pets. So no, I guess would be my answer. I don't see this changing the way we manage on-prem VMware-based VMs, at least today. I mean, NSX introduces some stuff. Newer versions of VRA offer scale up and scale down and all that good stuff. So yes, a little bit, but yeah, as far as just those naked vSphere customers, no.
You don't like swap without a week or something like you would.
No. Good luck getting an application owner to allow you to do that. Other questions? Yeah, she's waving at me, so we got like 1 minute.
1 minute.
Is there a way to start with an RDS instance using a snapshot? As part of the CFP when you're creating the RDS instance?
Yes, you can, but there's no benefit to it.
Yeah.
One thing I was thinking of is seeding the database when it started.
I would do like an import personally. Yeah, I would spin it up and then just do it. I mean, it's going to depend on how big the data set is. I mean, you're going to start to get, but yeah, I mean, once you start talking about CFTing like an RDS kickoff, that's getting a little out out of scope for this discussion, unfortunately.
But I found that it takes a really long time to bring up a Postgres RDS, and it's killing me. I tried to get the basic thing running, snapshot, use the snapshot to create, it takes just as long.
Is this RDS based or EC2 based Postgres?
Excuse me?
Are we talking like an RDS native or like in Postgres running on EC2? I just want to make sure I'm.
Postgres RDS.
Okay, gotcha.
What can I do? I mean, bring up just a bare minimum Postgres server in RDS.
It's taking forever?
It takes 10 minutes, 10 to 20 minutes.
I'm not aware of an issue with that. I haven't run into it personally. That doesn't mean it's not a problem. I just don't know if I can offer any insight because I haven't run into it personally.
Oh, so
I've
how
pr-
did you create a RDS Postgres?
I don't know because I haven't built one. I've primarily dealt with SQL and MySQL, so I can't personally speak to that. All right, she's waving me off. Thank you, everybody. Have a good day.